Welcome to those who are taking the PSSM course on the TIA portal and have already completed Module 5. Now we go to Module 6, which is going to be more theoretical. Same with an example in TIA portal, try to help them so that they know how the theory is transferred here. Now I am going to rely more on the PDF, since it is going to be more theoretical. See here, press Module 6, press PDF in Module 6. This video is going to be here, you are going to press it and it is going to open. This module is going to be from internal brands, I think it is worth it, if I go to remnants. The theory is important so that later they will know what they are using. First of all, we have already been using the internal brands in the previous modules, which are these M waves. Because they use them instead of the physical input that would be the I, because the M, we can simulate them in the TIA portal. We can force, it is much easier. On the other hand, the physical variables we would have to have a button or something to press and have it simulated in the TIA portal. These are examples of brands. For the characteristics they are these, which are internal variables of the PLC, they are not physical. They will be assembled in the Valerio Poliano, they allow programming to be simplified, they are used for slave memory and facilitate communication. They can be used in this industrial application. This is a basic example in which a brand could be used. For example, when the I0.0 button is pressed, which would be a physical one, it goes to an internal mark, and the internal marks can be entered, like this, or outputs like this. The mark is going to be stored, it is in storage, it is operating and then it is activated. For example, by pressing the I0.0 button the output is going to be activated, which would be an M0.0, and this in turn is going to close this contact, since it is with this. When this is activated, it is activated automatically, and then the motor is activated. These are the advantages, that in the end the brands are to help you with the issue of programming. Well, the global variables are, for example, the M, the I, the dB, we will see them later. For example, global variables could be these two. These are global variables, in which this is an M0.0, which I put a production contact, and it is a variable that I could use in different blocks of my programming. They could be like this, for example a running motor, it could be a Q0.0 output, auto mode should be a tick as this would not be a physical input or output. The automatic mode is a mark, the variables produced should also be a mark or a dB, in which they would be saved, and for how many stones are produced, the process temperature and speed was like this. Well, these would be the industrial applications. As I told you, they can be shared in 32 blocks, storage, bar, machine group, also exchange, information, recursion, they are HMI production variables and production variables. These are the advantages. For example, an example could be that we create the automatic mode variable with a flag, and we could later use it in the engine block, give weapons, security, production. Well, all the blocks can make the same variable, which we will already have assigned, as for example I have the production code assigned, I could use it in different blocks. Well, what are the remaining memories? Remnant memories are variables in which a count or something that they were sensing is stored. For example, production counting. Suppose you count how many boxes go through a production, and I don't know if you count 30 boxes, we then pay the PDC, that is, in a power outage, if we have it as a remainder, that with routine. What does this mean? That even if what I told you happens, that count will continue to be saved, that is, later it will still turn out that there were 20. And that is very important, because imagine if suddenly there is an outage or you turn off the PDC by mistake. That's going to erase the count, and that's what we don't want. So I'm going to explain to you here. For example, this is going to come out. It is not going to come out, just like that with a click. This is what you have to do, it's from here, and you put 1 in it. So, the M0.0, or 2, maybe M0.7, which I think is the maximum, is going to be with the routine. Let's do the test, let's see, with M0.7, see, there is up to 7, which limits up to 7. Okay, so here, well, now if you're explaining, you have to use this one. On 1, the retina is not in place, up to M0.7, it has to be maximum, right? Well, if they put 2, it will be set up to M1.7, and so on. And here this thing stuck to me. Come see, here I went. I see. Well, the retina, from what I told you, that for example, if the PLC turns off or there is a power outage. The production count, let's assume that there are 7,000 shells counted. If the PLC is turned off and turned on again, those 7,000 will still be stored in memory, and 7,000 will still be output. But if I didn't have the retina on, it wouldn't come out, it would go out to 0. Or it would start at 0. That's why it's important. For example, here's a practical example, which is a recorded production count, a total production of 15,800 pieces. And an outage occurs, when the power is restored, it will remain stored. Obviously, if they have the retina on, if they don't have it on, it won't be on. Imagine that there are 15,800 pieces that were counted, and they did not put the routine and a cut. It looks like 0 pieces. Imagine the problem you are going to have. So it's very important that you see that. This is the CPU conspiracy. The real applications, the ones that the remnants are used for, as he is explaining, there you read this. These are good practices. They have to use decorative names. For example, machine 1 production count. There are many machines, I don't know, it's called Sander, they call it. Counting boxes in Sander 1. See? Decorative. They have to use that decree, because it will help you later. You know if there is a fault in the connection, you have to fix something. If they do not have decorative names, they will not know exactly what the variable is. For example, engine. And they have 15 engines. And they only have the engine in it. Come on, they're not going to know what engine they're talking about, so they have to put engine 4. And thus they put the tick of the physical engine. You have to see there. One of these is a practical exercise of this ease. It has an internal mark that the more the engine starter has, I put the interlocking circuit. I have to put a mark here, they can put an engine here. Or you can put this one, click here, it's here, it's here, it's here. And I don't know, a mark down here, so that it is interlocked with the engine right here. They don't have a crane, they can remember the programming. There are times when you can program in several different ways, and the result will be the same. They have to do 2 practices, talk, talk. This is as easy as creating a variable mark, and putting it like this. And they use it in 2 blocks of red. I don't know, a manual one, an automatic one, and they put it on. This, they created production counting, and if you have already seen Module 5, you will already know how to use counters. They can use a CTU, and store its value in a retentive memory. They can make a brand, and they put retain on it, and that would be the exercise above. And yes, that is. This was a more theoretical module. It is not necessary to know about this theory. Because if they used the brands or the remnant things, the remnant brands, the DBs, all that, and they don't know what it is, obviously these things are going to be more difficult later on. So that. Enter the video of this video here, and I hope it helps you. Bye bye.